Today we're going to be looking at root matrices. For those of you that aren't at school, and even for those that are, this can be quite a difficult topic to understand because matrices can be difficult by themselves, and then we're adding this additional layer of complexity talking about the amount of possible roots between networks. So we're going to break this down slowly. This might be a bit of a longer video, but it's important that you understand these concepts, because if you get your networks wrong at the start, you won't be able to go through and do the more complicated questions. Now, with this, what we're doing is we're representing a network, so possibly roads between towns, and then we're using the organizational structure that a matrix provides to essentially simplify those calculations. So here I've drawn an example of, say, towns A, B, C, and D, and the possible roads between them. So if we look at town A and B, there is only one network or one route that you can go between those towns. But if we look at towns C and D, again there's one route. B and D, there's only one route. Right? So what we're going to do is we're going to use these matrices to show that. Now, some ground rules before going over this. Each town is represented both in the rows and the columns of the matrix. So the rows represent our from the town, and the columns represent where you're going to. So for instance, this element here would be going from town B to town A. Okay, and then we're going to list the number of possible ways that you could get to them. So I'm going to go through and start filling in this matrix, and you'll start to see some patterns emerge. So if we are going from town A to town A, how many possible roads allow you to do this? And the answer is there are none. There are no roads that you can go around leaving from town A and getting back to town A without passing through another town. So you're just going to simply put 0 in there. I'll change that to a different color. Okay. Now the next one, if we're looking around here, if we're leaving from town A and going to town B, how many possible ways are there to get there? So we're going from A to B, there is 1. If we're going from town A, so here, to town C, how many possible ways are there to get there without going through other towns? That's the important thing to remember. This is direct routes. So there is no way that you can get from A to C without going through another town. So there is 0. And again, how many possible ways to get from town A to town D? There are none that you can go through there are no possible routes that you can go through without having to go through other towns first. So again, there is 0. Then you go through and do this for each possible town, each combination. So now we're going from B to A. So again, if we're starting at town B, going to town A, there is one possible route that will allow you to do that. Going from B to B, that is impossible with this current network because there is no route that you can take that will allow you to get from town B to town B without going through other towns. So you have 0. From town B to town C, there is 1. And from town B to town D, there is 1. Now we move to town C. So from town C to town A, there is no route that you can take without going through another town first. So in this one, we'd have to go through B. So there is 0. From town C to town B, there is 1. From town C to town C, there is no way that you can do that without going through another town first. So 0. From town C to town D, there is 1. Okay, now on our last town, so from town D to town A, there is no way you can do that. You have to pass through B first. So there is 0. From town D to town B, there is 1. From town D to town C, there is 1. And from town D to town D, there is 0. Okay, now there are a few patterns that will emerge from this. One, you will notice that our diagonal here is all zeros. Okay, so that is because there are no loops, so no loop networks there is no possible way to return to start at a town and then return to a town without going through another town or another node. So your diagonal is going to be a set of zeros. Now another pattern you might have noticed is you have diagonals between your ones. So this one is mirrored, this one is mirrored, this one here is mirrored. You've got the 0 in the middle, but it's still mirrored in terms of distance, and this one is mirrored. That is because all of these routes are two ways, so you can go from B to A and A to B, your matrix will be a mirror version of itself. Okay, so this is important to know. As long as your routes do not have directions on them, your matrix, when you're finished, should always be mirrored along that diagonal. So that's another important thing to remember about doing these. Now I'm going to leave this video here about how you build these matrices, and then I'm going to do another one about what we can do to utilize these.